Hey, this is Brock Lemires, and in this video we're going to look at controlling a DC motor using an Arduino and an H-bridge. All right, so what is a DC motor? All right, so this is our little DC motor that we've kind of looked at in class, and it's very simple. It basically has two terminals, and you just apply a voltage to it, and it spins. And it's, it goes in, we talked about how it works is basically run electricity current through a wire that's in the presence of a magnetic field, and it creates a force. And so they put it in a circular form. And if you come along and you just touch a voltage to it, it will spin. Okay. And what's interesting about it is that if you put a big voltage on it, that means more current will flow and it really moves fast. Okay. But if you put a lower voltage on it, it just moves. It moves, like it still works. It's just that it moves slower. So let me try to get that on there. Here we go. We hold this to there, this to there. And you can see it's moving, but it's just slower. Okay. All right. So the other thing that's interesting about a DC motor is that you can run it both ways. So if I do it like this, notice that it's going essentially counterclockwise. If I turn the battery around, the thing still works. I mean, there's nothing in there but just wires going through a magnetic field. So if I do that, it spins the other way. So I can actually control the direction that it spins by switching the polarity back and forth. But you do notice right away, this thing will pull a ton of current. Whatever it can pull or whatever you'll allow it to take, it will take it. Okay. And so that's something we have to control. Now in your robot kit, you're probably looking at this thing and going like, what is this? And is this a DC motor? And the answer is, yeah, it is a DC motor. If you look at it, it's just a DC motor that's inside of this yellow gearbox. So if I came in here and I just pulled this off, you can look in here and you can just kind of wiggle it open. And what it is it's a DC motor, except that it has a little gear on the back of it. And if you look in there, there's all these little gears in there, and that allows it to slow way, way down. So it can spin really fast and have torque going and momentum. But then the chassis or the shaft that actually spins the wheels of your robot moves a lot slower. Okay, so then when you put it back in there, you kind of gotta wiggle it in so the gears link up. And this is cheap. I mean, if you pull this apart, you're probably gonna break it. So it's probably broke. All right. So the challenge of a motor is this: we have three things we have to do. We have to, number one, provide power to it because it draws too much current to be powered directly from a digital I/O pin from the Arduino. So you can't just connect it up to a digital I/O and then say like digital write high and turn it on. It would pull so much current the Arduino would probably burn up. So you have to supply power from a different source. And in our case, we're going to do that with a battery pack. The second challenge that we have with a DC motor control is that we want the ability to change the direction of it, which we saw was pretty simple, where you just switch the polarity of the voltage across it. But we want to do it without actually disconnecting it. Okay, it'd be horrible to have to actually disconnect and replug it back in to get it to spin the other way. We want to do it electronically under the control of the Arduino. And then finally, we want to be able to control its speed, because when it is allowed to pull as much current as it wants, it flies. I mean, it goes way, way too fast for most applications. Okay. So how do we do it? We control DC motors with a circuit called an H-bridge. And an H-bridge looks like this. And it uses this notion of electronically controlled switches. And so these switches, you can think of them as they have two states. They're either open or closed. When they're open, no current flows. When they're closed, current flows. And they're electronically controlled. And you're like, what kind of device does that? Well, it turns out that's a transistor. So imagine that you have a control signal that sits over to the side. And if you drive a high to the control signal, it'll close the switch. If you drive a low to it, the switch will open. So we can drive in 4 different signals in this example, and we can control the opening and the closing of all these switches. So then if we put the motor in like this, we have the ability to actually change the way the current flows through this motor. So let's look at when we do well, first of all, let's look at the power supply. We're going to provide that from a battery pack. So that solves the first solution. So this doesn't come from a digital write of an Arduino. But now let's look at how you could configure the switches to drive current through it. So if I close switch 1 and switch 4, current would flow from the power supply battery pack through here, through the motor, and then through S4, and then to ground. And it would spin one way. All right. But then look at this. What if I left those switches open and I instead closed S3 and S2? The current would flow this way And lo and behold, the motor would spin the opposite way. So an H-bridge is a circuit that consists of at least 4 transistors or electronically controlled switches, and you control the direction of the DC motor by closing and opening certain switches. In our example, one very simple way to do this is that if you know that S1 and S4 will always be either open or closed at the same time, you can take their control lines and wire them together and just use one signal. And you can do the same thing with S3 and S2 if you want to drive those together. And that way you could either have the thing completely open and off, or you could have one or the other closed in order to switch the directions. And you could actually do this with 2 control signals, okay? Danger though, if you close all 4 switches at once, the thing will just catch on fire. Okay, so then the final problem that we have is how do you slow the thing down? Well, it turns out that H bridges have an enable signal that it basically allows you to either drive the switches or not drive the switches. And so when you control the H bridge, you're going to have a control signal for the switch, but it will only assert if the enable line is asserted too. And asserted means it's high, okay? So by doing this, you can configure the switches that you want to close in order to drive the motor in a certain rotation or direction. And then what you can do is you can use a pulse width modulated signal on the enable line in order to essentially pulse those control signals and slow the motor down. Okay, so we know how to do this. We can do digital writes to configure the switches, and then we can just use a PWM that comes out of the analog write function of the Arduino to generate a PWM, and then we can just move this duty cycle to be bigger and smaller in order to speed up or slow down the DC motor. So that's how we're going to do this. Okay, so now let's look at the H-bridge that comes in your smart car robot kit. So this little fella right here is called the ELEGOO L298 motor drive control board, okay? And the L298 is the H-bridge chip. So this right here, you're looking down on it. This is actually up in the air. It kind of extends up into the screen. You'll see that when you hold your own. But this is the H-bridge right here. And then this little board has all these little connection points that you can do things like provide power to it. So provide power to the H-bridge, and then you can do control signals to turn on the switches and enables, and it's pretty cool, okay? So the first thing to know about this particular board is that there's actually 2 H-bridges in this L298 device. And so that's why you see output A and output B on this board. There are 2 completely independent H-bridges, other than that their power connection is connected together, okay? And so you have output A and output B, and what we're going to do in ours is we'll play around in this video about just controlling one DC motor using output A, and then when we build our robot up or connect this to our robot, we'll actually connect both write motors to output A, so that when you send the control signal from the H-bridge to them, they will actually both spin at the exact same time, either forward or backwards and at the same speed. And then we'll do the same thing over here on output B. But right now, let's just focus on one of the H-bridges, okay? So those are the 2 H-bridges that sit in there, and then you provide power to the H-bridge using your little battery pack that comes in your kit. Now, this is a lithium-ion battery. If you charge it up with just like a USB cable, and it has an on and off switch, so always make sure that it's off when you charge. And in fact, I'll show you when we start programming this. You want to make sure it's off when you download your program, get it running, and then turn it on and test it, just in case something's wired incorrectly. The way that it works is when you charge it, the LED will be green, and then once it's charged all the way up, the LED will go off, and it only gets up to like 8 volts. So this is a lithium ion, so it's only going to hold, its nominal is like 7 and 7.5, 7.6. But anyway, we will bring this in and we will put the power into this terminal right here, and then we'll put the negative side of the battery into here, into this terminal labeled ground. And remember, now you have a battery system over here, you have a board right here, and we have not connected our Arduino, so we're gonna have to actually tie all the grounds together once we get this thing going. Okay, then what you're gonna do in your robot kit is you will have 2 motors that are connected to output A, and then 2 motors that are connected to output B, and this will be your right set of motors and your left left set of motors. And you might wonder how you actually turn. Well, it's called skid turning or skid steering, where you basically, this is how like a bobcat works. So you just basically go forward like a tank, and then if you want to go backwards, you go forward on the right, or if you want to turn left, you go forward right and backwards on left, and you just skid and turn on a thing. But that's fine. It works. And then what we're going to do is we're going to use obviously the Arduino to generate control signals, but we're going to put the Arduino shield, the breadboard shield on top of it so that we can kind of connect all this stuff together. Remember, we're trying to like examine what's going on as you do this, but we're going to send 6 control signals from the Arduino over into this H-bridge board, and 3 of them are going to be to control the right motor, 3 will be for the left motor. And if you think about the 3 that we're going to do, you're going to need 2 inputs which control sets of switches on the H-bridge. So for example, switch 1 and switch 4 will be on one control signal, and we'll probably input 1. And then S3 and S2 will be on another control signal. So they already wired these together. So one H-bridge only takes 2 input signals in order to make the connections to control whether it goes forward or backwards. Then the enable line is we'll drive into that a pulse width modulated signal, and that's how we'll throttle it up or down. So if we do a PWM if we configure the switches to go forward and then we put a PWM in there that has a duty cycle of 0, which means it'll always be low, the motors won't move. If we put a PWM that is 100% duty cycle, it'll be high, and that'll be the fastest that the motor can go. And then as we put in duty cycles in between 0 and 100%, it'll increase or decrease in speed accordingly. Okay, so that is the setup that we have. So let's control one motor. Let's build a circuit that connects everything up and see how to do this, and then we'll write the Arduino code to actually make it spin. Okay, so here's kind of the schematic or topology of what we're going to do. So we have this H-bridge chip. We're only going to use one H-bridge, okay? So we'll use output A, which is the one, if you orient it like this, it's the one at the bottom. And so we'll use it to control one motor. And what the first thing you want to do is you want to connect your power supply to this terminal strip right here. Okay, so these are screw terminal strips. And so what you do is you bring over the red terminal of the battery pack and you screw it into there. And I'll show you how to actually do this in a second. Bring the ground over to there. So now the battery ground is connected to that, so you have a common ground. But you also need to throw in one more wire to the shield, which is plugged into the Arduino, so that everybody has a common reference or common ground. So you're going to need 2 wires to get that ground in there. And then what you do is you take output A and you basically take the red, or take a red wire of this little fella and wire it into this terminal strip, this screw strip. And then you take the black and go to there. So now your motor's hooked up, and it will be controlled by the H-bridge, and the H-bridge will be powered by this guy. And then the Arduino will send in the digital control signals that go from 0 to 5 volts, okay? So you're gonna have 3 control signals in here. You're gonna have input 1, input 2, and enable. And input 1 will control switches S1 and S4, which are wired together in the H-bridge. And then input 2 will control switch 2 and 3, which are wired together in the H-bridge. So basically what you can do is you can have all the switches open, or you can have S1 and S4 closed to make it go forward, or open those back up and make S3 and S2 closed to make it go backwards. You never want to turn both of these suckers on at the same time, or it'll heat up your H-bridge. No good. And then remember, once we configure the direction, we can set the speed by doing the enable line, and we'll wire that up to something that can do a PWM. So when you look at this, what you want to do is put input 1 to digital output pin 2, and you want to take input 2 to the little H-bridge board and connect it to pin 11 of the Arduino. And then we want to use the enable, we'll call it enable A, connected to pin 3. Now pin 3 on the Arduino is going to have the tilde by it, which means we can generate a PWM signal using the analog right connection. Okay, so now let's take a look at my setup. Okay, so when you come over here and look at this, here's the board right here. Okay, or excuse me, here's the power pack. And what you're going to do is you're going to want to use a combination of wires that are male to male and male to female. So in this situation, if you look at this connection is a male, it's got the pin, and I can actually plug that directly into this receptacle of the battery pack. So I have a black and a red wire, and they're both male to male, okay? And then I have this in the off position. And when I come over to here, what I do is I basically take this little screwdriver that came with my kit and I can essentially just disconnect it. So I come over here and I just unscrew that thing. And what I do is I just take that male pin and I can just kind of slide it in to that, the little teeth right there. And the way a screw terminal works is it's meant for like bare wires and it just mashes down on it to make a connection. But you can do it with these pins as long as you're kind of gentle. So I can make it snug. And I got that little guy connected. So now I have a ground and power, or actually it's just the plus and minus of it. And everything's off right now. And then what I have over here is I have my Arduino with the shield. And what I did is I took the ground strip, or the ground screw right here, and I actually was able to stick 2 of the connectors into there, or 2 of the wires into there, and it had enough room to do that. And then so that I had one that went over to here to the shield, and it goes into the ground on this particular connector. And then what I have is I have 3 control signals. And so this bottom one I made purple. That's going to be A enable, which we'll call E and A, or enable A. And I connected that to pin 3, which is over here. And then I took in 1, which was the next one up, and I made it yellow, and I brought that over here and I put it on pin 2. And then finally I took in 2 and I brought it over to pin 11. And there's rationale for that because you'll see later. Okay, and then finally I have my little motor right here, and what I did is once again I used 2 male-to-male wires, and I stuck, this little fellow there, and then I used the screw terminal here and I put them into there. So now what I have here is power, it's off. I have my Arduino, it's wired. I have my H bridge, and I'm gonna use output A to control this guy, and then I put a little piece of tape on the shaft of this motor so that I can actually see it, because when it spins you can't see it on the camera really well. So that's what we have. Okay, so that's our setup. So now let's consider the code that will actually make this circuit run. All right, so consider this. You are going to send 3 statements or 3 commands to control the signals in order to make an H bridge work. Okay, so if you look at where in1 is, it's on pin 2. That's the way we wired it. And that will control switch 1 and 4 of this thing. So in order to configure it, and in this case, let's put it to a low so that they're open, I would do a digital write to pin 2 and then say low. Okay, and over here in the comments, I say that in1 is how you would make the motor go forward in this situation. Okay, so that's an example of a statement that you would use to control whether the these 2 switches were open or closed. Okay, and in this case they're open. Okay, then if you wanted to control in2, our connection in2, you would do another statement that goes to pin 11, which is where we wired it, and that would control switch 2 and switch 3 in this schematic right here, okay? And so in that situation, I drove them to low, so that means they're open, all right? And over here in the comments, I put in2 equals backwards, and that's, you'd make it spin the other way, okay? And then you get the directions configured the way you want them. Then you do this analog write command on pin 3, and that's where we connected it. And remember, pin 3 has a tilde, so you can use that analog write. Now, it is not an analog signal on the output. It's a PWM that you're allowed to automatically generate a PWM at, I think it's 980 hertz at 2 millisecond period. And then you provide the duty cycle as an integer between 0 and 255. Okay, so 0 is no duty cycle, it's all low. 255 is all high, and in between is a range of duty cycles. So then over here, I would give a comment of enable A. So these 3 statements are how we would configure this. So let's take a look at what it would look like if I wanted it to move forward. So what I would do is I'd use those same 3 statements, and instead I would go to in1, which is on pin 2, and I would write a high to it. And what that would do is it would configure a path through the DC motor like this so that it is going to spin in one particular direction. Then in order to enable it, I would give a duty cycle in this 3rd command of something other than 0. So in this situation, I'll put it like 100. That'll spin, I don't know how fast, we'll see in a second. And that's how you do it. So those 3 commands are how you do it. How would you do it if you wanted it to spin the other way? You would simply write a low to pin 2, which turns those switches off, and then you would run a high to in2, which controls these 2 switches, and that would put a path for the current going the opposite direction through the DC motor, and that would configure it to spin the other way. And then you would still do an enable PWM signal using analog write to pin 3, and again we use a duty cycle of 100. Okay, all right, so let's do it. All right, so I have my entire circuit set up. I have my battery power, or my battery powered off. And what I want to do is I want to create a new Arduino sketch. All right, so I created my new Arduino sketch right here. And what I'm going to do is let me save this off the bat so that we have it. And so I've been saving on my desktop here. So I go to sketches and we'll call this 05 underscore DC motor H. H bridge. Okay. All right. So there I am. All right. So then I come along, and what I want to do is you always want to use the serial monitor to kind of to print the status of what you're doing. So let's go serial.begin, and we'll give it a 9600. Nice and slow. It works. And then let's do this. I'm going to write the 3 commands in order to get the H bridge to be in the off position. And then from then on out, I can actually just copy and paste it. So what I do is I do digital write, and I go to pin 2 and I say low. Okay. And that, if you recall, is in 1, meaning forward. Okay. And then 1 equals on, or I could say high equals on, low equals off. Okay. As a comment. And then what I can do is come down here and go digital write. And now this is going to be the other 2 switches in the H bridge. And I say 11 low. And then over for my comment, I can do into equals backwards. And it just means the other way. And again, I could say high is equal to on, low is equal to off. Okay. And then, okay, that's fine. And then finally, I'm going to do my analog write. And this sends out the PWM. And I send that to pin 3, and I give it a duty cycle of 0, which means just make it low. And then I come over here, and my comments will be enable A, and I'll say high equals enabled, low equals disabled. Okay. All right. So now I'm sitting there, and I'm also going to put a little delay in there, 500 milliseconds. So these 4 commands right here are basically the magic control of the entire H bridge. Okay. So what I'm going to do now is I did the serial, everything's great. And what I want to do now is let's put a serial print statement up here. So serial print, I'll say, don't move. Okay, and so that's that. And now what I'm going to do is I'm going to do a lot of copy and paste. And so I'm going to verify this and just make sure that I don't have any screwage on my syntax. It looks like it didn't. And now think about what I'm going to do now. I'm going to take this entire chunk of code, and I'm going to come down here into my looper. Okay, so I'm going to make my serial monitor just a little bit smaller, and I'm going to come right here and I'm going to paste it. And now what I'm going to do is I'm going to say move forward. Okay, so forward, dot, dot, dot. And in order to make it go forward, I go high, okay? And then for my duty cycle, I go 100. And then what I'm gonna do is I'll stop it, okay? So then I'll say don't move, and it'll do what I had on my clipboard right there. Okay, so I'm going to print this, and then I'll make it move for half a second, and then I'll stop. Then I'll move for half a second, and then I'll stop. And let's make sure that this works, and then we'll rock and roll. Okay, so I'm going to come over here to my board, and I got my battery pack off. Plug in the old Arduino, okay, and then I go ahead, let's upload this, and then let's test it and make sure everything's cool. All right, so it's uploading. Life is good. Okay, done uploading, and I'm sitting here going, I don't even know if it's working. So let's open up the serial monitor and see what's going. So I should be getting some messages coming out. Don't move, move forward. Don't move, move forward. Okay, so now I come over here, moment of truth, and when I turn on the battery pack, that will provide power to the H bridge, which will provide the control signals to the DC motor. My digital signals are moving right now, so they're sending over to the H bridge. It just doesn't have any power. So here I go. I'm going to see if this works. And oh baby, it works. Forward, 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 forward. Okay, all right, sweet, you did it. All right, so now we just want to test a little bit more. Let's do backwards. Okay, so I'm going to copy this entire thing, and I'll come down here. And obviously we're going to figure out how to make this a little bit better as we go forward. But I'm going to make this go reverse. And then let's come in here and say, what does it do to make it go reverse? You switch these guys, and that now makes it go in reverse, and then it'll say, don't move. So if you look at this code, let me see if I can zoom out at all. Let's see. No, you cannot. Okay. Okay, so basically, I know it's kind of hard to see on one screen, but I've got move forward, then don't move, then move reverse, and then don't move, and then loop forever. Okay, so let me save that, and I'll compile this up, and I got my little fellow over here, going over here, and it should download. I'm going to leave this battery pack on, see if it works. Look at it. Look at it. It's going forward. It's going backwards. It's going forward. It's going backwards. It's going forward. It's going backwards. All right. Last thing I want to look at when this is kind of fun here. So let's do this. Let's open it all the way up. Let's do 255 on the enable duty cycles, and that will give it the fastest speed that this thing can go. And so let's go ahead and fire it up. And then what we'll do is this should spin faster. Oh boy. Oh boy. Here we go. So that's pretty fast. It's actually not as fast as the DC motor is running because it's geared down inside of that yellow gearbox. But that is how you control the speed. Okay, so we've done everything we wanted to do. This is actually really cool. One thing though that, now all I got to do is turn this off to make it quit spinning. One thing though that kind of is bad about what we've been doing is that it's very unreadable. Like we're hard coding in numbers and everything. It's for the pins, and it's like it's time to stop doing that and let's start using this thing called pound define to create some basically user defined names. Okay, so what pound define does is it allows you to make kind of a readable word that you can use in your code, and anywhere it sees that, it will substitute a value. So in this situation, I defined in1 as 2. So anywhere in my code I use in1, it will replace it with 2 when I compile. And then I did the same thing for in2 and enable ENA. So I said in2 is going to be defined as 11, ENA as 3, so that when I write my code, I can do it like this. And it's a lot better to write it like this because it's readable. Digital write to in1, make it low, and that's good to go. All right. So if I came back to my Arduino code, you do those at the very top. Pound defines are kind of right above even the setup. And you go pound define, and then the syntax looks like you don't even use semicolons. You just go in one, and then 2 is a sub, and you can have comments. So this will be basically if you wanted to do comments that kind of match the way your robot is going to work, it's right motor forward or something like that. Okay, and then you can copy and paste that, and you can go boom, and you'll say in 2 is going to be, that's pin 11, and this is going to be right motor backward, and then you're going to go boop, and you come back here and go enable A, and that's pin 3, and this is going to be right motor enable. And now when you come down here, you can go, okay, instead of having a 2, make it in 1, instead of having 11, make it in 2, and instead of having 3, go enable A. All right, so now I'm sitting here and it's like, okay, that's pretty cool. How can I use it now? So now I take these guys, let me clear my entire code out of my loop, and let's now use the good syntax. So what I'm going to do is I'll say, let's do a serial print and go forward. And then what I do here is I say, make this high and clean my comment up and good to go. All right. And then what I can do is I can come down here and do another paste of this. Okay. So now I'm going to go, boop, don't move. And then now what I can do is, so excuse me, I did a high there, and then let's do like, I don't know, 222. So let's do like 200. So it's pretty fast, but not as fast as all out. And then I'm using readable code. So now all I do is I can copy this entire thing, and I can do, if I paste that, now what I can do is say reverse, and I can come here and say no, no, yes, yes, and I got it. Okay, so here we go. Misspelled backwards. All right, that's cool. All right, so let's go ahead and download it. And what this should do is it's got a compile error. Oh, got a little sucker in there. Whoops. So I got that. Extra double quotes. So let's see if this works. All right, we downloaded it. I got my motor is off. The only way I really know if it's running without that thing is forward, don't move, reverse, and let's see how it goes. And oh, baby. You did it. All right, that is it. That is how you control a DC motor with an H-bridge, and that is how you use pound defines to make your code a little bit easier to read. All right, nice job, and we'll see you.